Object is a square prism. Side of its base is 30 mm and height 70 mm. Has its base in HP. So it is resting on its base on HP with one of its side is 30-degree inclined to VP. So let's say this is XY line and this is a 30-degree line. So the side of its base is 30 mm. So the square to be drawn having a side length of 30 mm. So this is A, B, C, D and 1, 2, 3, 4 because it is a square prism, so it is going to have square at the top as well as bottom. So 4 corner points for the bottom face and 4 corner points for the top face. Now project it for the front view. The height of solid is 70 mm. Okay, so let's say this is a base. What is the nomenclature? Let's say this is A dash, B dash, C dash, D dash, 1 dash, 2 dash, 3 dash and 4 dash. Now it is cut by a cutting plane 60-degree inclined to HP. The cutting plane is inclined to HP. So in front view you will get the cutting plane. If cutting plane is inclined to VP, then cutting plane is going to be visible in top view. Okay, so it is inclined to HP at 60-degree perpendicular to VP and cutting the axis at a point of 20 mm from the top face. So let's locate the axis first. So this is going to be the axis. So axis represent it with a center line at a distance of 20 mm from the top. So let's say this is the point, 20 mm from the top. Over here draw one reference line parallel to XY and from here draw one line which is inclined at 60-degree. It is inclined at 60-degree. Okay, let me correct that one. So this is the cutting plane. Now when you draw cutting plane, it is basically a center line having thick ends. Ends are going to be slightly thicker. Whenever cutting plane appears in front view, name it VT. If cutting plane appears in top view, name it HT. VT stands for vertical trace, HT stands for horizontal trace. Now the object is being cut from one end to other end, so it is cutting certain vertical edges as well as it is cutting the top face also over here. So we need to provide names to all those intersection point. Now let's identify the intersection points. This is intersection on the a dash 1 dash, so let's say this is a dash. This is on the b2, so let's say, sorry, we need to provide some different names. So let's say this is p dash, this is q dash, this one is r dash, and at the top, this intersection with top face is actually going to intersect the solid at two locations. The first intersection will be in between b dash c dash, so let's say that point is s dash. Additionally, there is one more line c dash d dash, and that is also going to be intersected. So over here there are going to be 2 points, s dash and t dash. So total 5 intersection points. Now once you have located those 5 intersection points, let's project those points in the top view. If you look at the question, it clearly specifies that draw front view. It's just a front view. So in front view, it is going to be a cutting plane, not a sectional view, whereas sectional top view, so in top view there is going to be some sectional view and true shape of the section. So project those points. This p dash, it is on a dash 1 dash. Where is a1? Over here. So at the same location there is one more point p. Similarly, this q is on the b dash 2 dash, so this is b2. So this is going to be one more point, that is q. Where is r? It is on d4, so this is going to be r. Now s and t. S and T is intersection with the top face in between BC and CD. So let me use different color. Project this CD, project this T and S and T vertically downward on the edge BC and CD. Where is BC? This is BC. So this is going to be S, and another intersection is on CD. So this is intersection of that projector with CD, and this is going to be the point T. Now once you have located those points, highlight that portion. So this is going to be a sectional view. Now when you draw that sectional view, it is to be filled with section lines. For this front view as well as this top view, reference line is this XY line. So the sectional lines that you are going to draw in this highlighted portion are to be drawn at an angle of 45 degree to XY line. So you need to draw lines which are inclined at 45 degree to XY line, and the distance between two lines, you can take any random distance somewhere in between 1 to 2 mm, but that has to be uniform from one end to the other end. Okay, so this is front view, this is sectional top view because it consists of a sectional view also. The last view is true shape of section. Now to draw true shape of section, or why do we need to draw true shape of section? this cutting plane is inclined to HP. In front view we are not getting any section. In top view there is representation of the section of the that's solid, but as cutting plane is inclined to HP, the top view that you are going to get, it is not going to show the true dimension because line is inclined to HP. Okay, so to draw that true shape, what we need to do, we need to consider one auxiliary reference plane which is parallel to the cutting plane. Cutting plane is this VT that we have drawn. We need to assume one auxiliary reference plane which is parallel to this cutting plane. You can consider it any wherever space is available. You can draw that cutting plane over here also. That is not the constraint. The one condition has to be stick to, and that is the cutting, this reference plane has to be parallel to our cutting plane. So let's say this is x1 y1. I am not going to consider this plane because there isn't any space available. Now once you have drawn that additional reference line x1 y1, draw every single point from that cutting plane. What are those points? These p, q, r, s, t. From all those points we need to draw projectors up to this xy line and extend beyond xy line as well. Now while drawing these projections, one condition we need to follow, and that condition is all those projectors has to be perpendicular to the cutting plane. We have taken projections from that cutting plane, and while projecting those projectors has to be at right angle to the cutting plane. So we have taken a reference from the front view, right? This is front view and we have taken projections from the front view. In some examples there you might get cutting plane in a top view, and in that case you will take projections from the top view also, but for this example we have taken projections from the front view, so we have used front view. Now we need to use the top view. Okay, now how we are going to use that top view? Let's say I am going to locate the point P. This is the projector of the P. I will take a distance of a point P. Let me take any other different color. Okay, let me take this violet color. Take the distance of point P from original xy plane. So from here take a distance of this point P in a compass. The projector of the P on this newly created reference plane x1 y1, keep compass over here and locate the point P. Okay, what I have did, I have taken distance of the point P from the xy line and marked with reference to x1 y1 line. Similarly, let's say I am going to locate the point Q. Take a distance of point Q from the xy line. This is going to be the reference. Keep compass on the projector of the Q on x1 y1 and mark the point Q. Similarly, I am going to locate the point R. Distance of a point R from the xy line, this much distance. Take that distance in compass. Where is the projector of the R? This third line. Keep compass on x1 y1 and mark the point R. So let's say this is point R. Similarly, locate the S and T. The projector of the S and T is this vertical line. Take distance from xy. Projector of the ST, the last one. Keep compass at x1 y1 locate the point S. Similarly, take distance of T from the XY on the same projector from X1 Y1 and mark this point T also. Okay, now for the nomenclature of this true shape, we have taken a reference of the front view. We have projected points from the front view, so we are drawing the view opposite to the front view. Opposite to the front view, it is going to be top view, right? It is front view where we are getting cutting plane and we are looking at true shape, so we need to go for the opposite view of that front view, so it is going to be top view. In front view, we have taken nomenclature P dash, Q dash, R dash, S dash. So ideally it has to be PQRS, but in this basic top view, this PQRS is already taken. So this nomenclature is going to be P1, Q1, R1, S1 and T1. Okay. And finally, the solid is a prism which has got a flat faces, and section plane is also a straight line. So the section that you are going to draw, every point is to be connected with a straight line. Okay, so connect all the point with a straight line with each other. So let's say this is PQ, this is S, this is T, this is R, and this is P. So this is true shape of the section. Now for this true shape of the section, reference line is this X1 Y1. So the section lines that we are going to draw over here are to be inclined at an angle of 45 degree with the plane X1 Y1. 45 degree to X1 Y1, and same equally spaced at a distance of in between 1 to 2 mm. So this is going to be the final solution. A cylinder of 50 mm diameter and 60 mm height is resting on its base on HP. Let's say this is XY line. Object is a cylinder resting on its base on HP. Base on HP means shape of its base is going to be visible in HP, and that is nothing but in top view. So solution is going to start from the top view. So let's draw the circle in the top view. Now split that circle into certain equal divisions. This is first, second, third, fourth, fifth, sixth, seventh and eighth, and as it is cylinder, it is going to have circle at the top, circle at the bottom. So there is going to be overlapping of 2 points. So this is A, B, C, D, E, F, G and H. Okay, next project all the points for the front view. the height of the cylinder is 60. So let's say this is 60. Highlight the outer lines and keep the remaining lines as it is, because those are the generators that we have created for our reference. One dash, 2 dash, 3 dash, 4, 5, 6, 7 dash and 8 dash. Okay, so this is the basic view. Now let's talk about the section plane. It is cut by a section plane or cutting plane perpendicular to VP. Perpendicular to VP, inclined to HP. So the cutting plane is going to be located in front view, and top view is going to be a sectional top view. Even that is that you can get from the question itself. In the end, if you go through this last statement, draw its front view. It is not sectional front view, just front view. So in front view you are going to get the sectional plane, whereas sectional top view, so in top view section is going to be there and true shape of the section. So what is condition? It is cut by a cutting plane perpendicular to VP, 45 degree inclined to HP, and passes through midpoint of the axis. So what is axis? It is going to be overlapped with this central line or the generator at the center. So locate midpoint of that central line, create one locus parallel to XY line, and draw a line which is inclined at 45 degree. So let's say this is going to be the cutting plane. Let me highlight this cutting plane. So this is VT. Now once you draw a section plane, the part between the observer, so observer you will be located over here, observer and cutting plane, the part of the solid falls between observer and cutting plane. So this upper part is going to be discarded, so remaining part is to be highlighted. So this is going to be a straight line. This is the base, and till the cutting plane this line is also to be highlighted, and beyond that the top portion is going to be a regular line. Okay, so always highlight this remaining portion of the solid, or it should be differentiated from the part which is going to be discarded. So this is the cutting plane. Now mark the intersection points. So there the circle we have split it into 8 equal parts, cylinder being cut from one end to other end. So there are going to be 8 intersection point in between this cutting plane and solid. So this is, let's say, P dash, Q dash, R dash, S dash, T dash, U dash, V dash and W dash. So these are the 8 points of the intersection between cutting plane and solid. Okay, so this is front view. Now we are going to draw a sectional top view. Now in case of sectional view or sectional top view, the solid is being cut from left end to right end, so the whole cylinder is going to be cut. So in top view this complete portion has to be highlighted. So draw a section line, incline at 45 degree to XY line and equally spaced at a distance of 1 or 2 mm. So this would be the sectional top view. Now to draw a true shape of section, what we need to do, we need to draw one auxiliary reference plane which is parallel to XY line, cutting plane. The cutting plane that we have drawn, draw one line which is parallel to this cutting plane. It is going to be parallel to VT. So this is X1, Y1. Once you locate that cutting plane, auxiliary reference plane X1, Y1, draw projections from all the intersection points that you have located in a front view. The projectors must be perpendicular to the cutting plane. The projectors that I am drawing from that individual point, those are perpendicular to the cutting plane VT. Okay, so as I mentioned earlier, to draw true shape of section, we are supposed to refer front view as well as top view. Now the cutting plane we have got in front view, so we have taken projections from the front view, so utilization of front view is done. Now we are going to use the top view. Now how we are going to use that top view? Let's say I'm going to locate the point P. Okay, that part somehow I missed. So this intersection point has to be represented in top view also. So this is going to be P, this is Q. Why I'm locating at the 1A only? Because P point is located on A1. So it would be exactly at the same place. Similarly, Q and W are on B2 and H8. So B2, Q, and at the H8 you will get the W. Similarly, this is R, this is V, this one is S, this one is U, and this one is T. Now I am going to locate the draw the true shape of section. So as I mentioned, we have already utilized front view and now we are going to refer to the top view. Let's say I am going to locate the point P. Take distance of point P from the XY line. So distance of point P from XY line in a compass. The projector of the P, keep compass on XY, X1, Y1 and mark this point P. Similarly, I am going to locate the Q point. So take distance of Q from XY, keep compass at X1, Y1, locate the point Q. To locate W, take a distance of W from XY and mark that point W. Similarly, R and V, so distance from XY, distance from XY, keep compass at X1, Y1, let's say this is R and this one is V. Similarly, distance of S from XY, projector of S, keep compass at X1, Y1, locate the point S. Similarly, to locate the point T, take a distance of T from the XY, keep compass at X1, Y1, mark that point, what is that point? V. And finally, T point, so take distance of T from XY, projector of the T, the last projector, keep compass at X1, Y1, over here and locate the point T. Now about the nomenclature, the cutting plane we have got in front view. To draw true shape, we are going to draw opposite of the front view, so that is nothing but top view. In front view we have used nomenclature P dash Q dash R dash, so this true shape should be named PQR, but this PQR already utilized in top view, so this is going to be P1 Q1 R1 S1 T1 V. Okay, that was the point U1 V1 W1. Okay, and once you have located all the points, the solid with which we are dealing with is a cylinder, so it is going to have a curved surface. So the points that we have located, all those points are to be connected with a freehand curve. Okay, and finally draw section lines which are inclined at 45 degree to x1 y1 line and must be equally spaced at a distance of 1 or 2 mm, but that distance should be uniform. So this is going to be the solution for this specific question.